Okay, so for this particular lesson on 4.2, we're talking about properties of triangles. Most of these properties you probably are already familiar with, but the sum of the angles of a triangle is always going to be 180 degrees. So how would you solve for the measure of each angle here? Well, you want to add all three of these angles up to be 180. By combining like terms, you would get 6x plus 6 equals 180. When you subtract 6 from both sides, you get 6x equal to 174. When you divide by 6 from both sides, you're going to get x equals 29. So if you come over to the triangle, then you know this one angle here on the right is going to be 29 degrees. The angle at the top left, when you plug in 29, comes out to be 55 degrees. And when you plug in 29 to the angle on the bottom, you come out to be 96 degrees. So this triangle, classified by its angles, would definitely be an obtuse triangle because one angle is greater than 90. If we asked to classify it by its sides, then it would be scalene. So this next one, if you know that two angles of one triangle are congruent to two angles of another, then you should also know that the third angles have to be congruent as well. So if you know that the angle up here on top is 82, then because the way that it's marked, this angle also has to be 82. Whoopsie. This angle also has to be 82 degrees. The angle here that's marked with 2 tick marks, that's 67 degrees, which means this guy right here has to be 67 degrees. So this guy over here is 67 degrees. And then what's the missing angle? That's x. Well, you need to add up 82 and 67, which gives you 149, and subtract 149 from 180. And that's going to give you 31. So this angle here at x is 31, which means this angle over here must also be 31. The acute angles of any right triangle have to be complementary. They have to add to 90. If one angle is 90 already, hold on a second, C-O-M-P-L-E-M, oopsie, hold on. Let me fix my spelling and let me move this recording thing down. So there we go, are complementary. Okay, so we got complementary. So the fact that you've got one angle being 90, but all three angles have to add to 180, then the other two must have to add to 90 as well. So if we're trying to find the other two angles and we do an equation, we can combine like terms, and we can end up getting 4x minus 2 equal to 90. Add 2 to both sides. Divide both sides by 4, and x comes out to be 23 degrees. And then we know that this angle up here must be 17 degrees, and this angle down here is 73 degrees. You don't have to do the two angles adding to 90. You can do all three angles adding to 180. It doesn't matter. It's whatever you prefer to do. When you have a right isosceles triangle, then each acute angle has to be 45 degrees. And that should make sense because if it's isosceles, then in a triangle, the sides opposite the congruent sides, the angles opposite the congruent sides are congruent. So each of those guys have to be 45 degrees. If you're dealing with an equilateral triangle and all three sides are the same, then all three angles must be the same, and each angle here must measure 60. Okay. So the next thing talks about exterior angles and then adjacent interior and non-adjacent interior. So the exterior angles is always when you extend a side. So for example, angle 4 would be an exterior angle, as would angle 5, as would angle 6. Those are all outside of the triangles. Well, if you look at angle 4, the angle that's adjacent to it, attached to it, would be angle 1. If you look at angle 5, the angle that's attached to it, the adjacent angle would be 2. And if you look at angle 6, the angle that's attached to it would be angle 3. So those would be considered your adjacent interiors to those particular exteriors. Well, the other interior angles that are not adjacent would be the other two that are left. So if we're looking at 4 right here, and if 4 is the exterior, then 2 and 3 are the non-adjacent interiors. This would be angle 2 and angle 3. If you're looking at 6 as your exterior, then the non-adjacent interiors would be 1 and 2. So angle 1 and angle 2. And then if you're looking at angle 5 to be your, oh, I think that's in the wrong spot. Hold on, let me fix that. Hold on, sorry about that. We're in the wrong place. So angle 4's non-adjacent is angle 2 and angle 3. Angle 5's non-adjacent interiors are angle 1 and angle 3. And angle 6, that non-adjacent interior is angle 1 and angle 2. Well, there is a special relationship between the exteriors and the non-adjacent interiors. And I'm just going to kind of show you something right now before we fill in the next two bubbles, or the next two fill in the blanks. If we were to pick an exterior angle at 4, let's say being 100 degrees, then what would have to happen is angle 1, the supplement, would have to be 80. Well, if I wanted to find out what 2 and 3 were, I would have to realize that angle 2 plus angle 3 somehow better be 100. Whether it's 50 and 50 or 70 and 30 or 60 and 40, it doesn't matter. But because all three angles of a triangle have to be 180, if we know one of them, we know the sum of the other two. And there's something special about the exterior angle and the sum of the non-adjacent interiors. Let's try that again. If, and I'll give you some different stuff. Let's say in here was 60 and out here was, I don't know, 110. If we wanted to find some missing angles, we'd have to say, well, 1 is supplementary to 4, which means 1 better be 70. And angle 3 would be 70 plus 60, or 130. 180 minus that would be 50. And now if I look at that exterior angle again, and the non-adjacent interiors, 110 is equal to 60 plus 50. So you have just learned a really good, I guess, theorem, if you will. If we go to the second bullet, so I'll go back to the first one in 1 second. If we go back to the second bullet, what you're going to have in here is the exterior angle of a triangle is always going to be equal to the sum of the two non-adjacent interior angles. And we just kind of proved that to you already. So one way you could do this is find out all this particular example is you could find out the supplement of 110 and then figure out what x is going to be. Or if you use this new theorem, you could say, well, 110 is equal to the sum of the two non-adjacent interiors. And then x, when I subtract 60 from both sides, is in fact 50 degrees. Okay? Notice also, and I'm going to put 50 in here, notice also the bullet above it. It says the measure of an exterior angle of a triangle is blank the measure than either non-adjacent interior. Well, let's do the example that we just did. If I put 110 here, and I put one of these guys to be 60 and one of these guys to be 50, isn't it true that angle 1 is greater than angle 2? And isn't it true that angle 1 is greater than angle 3? And that's always going to be the case. The measure of an exterior angle is always going to be greater than the measure of either non-adjacent interior. We know the exterior equals the sum of the two non-adjacent interiors, but the exterior is greater than either of the two non-adjacent interiors. I'm just going to do one more thing, kind of using this picture down here, that angle 1 is equal to angle 2 plus angle 3. Okay, with all of that, now there's some sample problems that you can do, and we'll try to do these. If I can, oops, back it on up. Okay, so this first one, it says to you, and I'll bring this over and I'll go there. Okay, so the first one, in triangle ABC, an exterior angle at C measures 110, and the measure of angle A is 40. The triangle must be. Well, you're going to have to draw a picture. So I know I've got an exterior angle, so I'm just going to draw a triangle with an exterior piece. I know that the exterior angle is at C. which means A and B, it doesn't matter where you put them. So I'm just going to put A over here and B over here. Doesn't make a difference. But the exterior angle at C is 110. It tells you angle A is 40. Well, if that's the case, what kind of triangle is this? Well, fill in the other missing pieces. If it's 110 over here, then B has to be 70 because the adjacent is equal to the sum of the non-adjacent interiors. The exterior is equal to the sum of the non-adjacent interior, sorry. And then C has to be 70 because it's supplementary. And now I have two angles the same. If these two angles are the same, then the sides opposite them must also be the same. So the type of triangle this would be is isosceles. And the next one, triangle DEF. I would be drawing another picture, and it's talking about an exterior angle at E. So if we were to draw DEF, this has to be E. Doesn't matter where the other ones are, makes no difference. But DEF, D is x plus 10. F is 3x. And it says the exterior angle at E measures 5x minus 20. Well, we know the exterior angle is equal to the sum of the two non-adjacent interiors, which means I'm going to set up an equation. I'm going to add the like terms at F and D, which gives me 4x plus 10 equals 5x minus 20. Subtract 4x from both sides to get 1x, add 20 on both sides to get 30. When you start plugging stuff back in, if x is 30, that at F you'd be 90. At that point you can really stop because you're going to have to be a right triangle. You can still plug in for all the other ones should you want to. This would end up being 40 and this would end up being 50, but it's still a right triangle. Okay, let's keep going and finish up these extra problems. 3, it wants an exterior angle of an equiangular triangle. Well, if this is 60 on the outside, on the inside, then it's going to have to be 120 degrees on the outside. On 4, you've got two different isosceles triangles. If this top vertex angle is 56, each base angle measures 62 because 180 minus 56 divided into 2 is 62 each. 62 supplement over here would be 118. And now you're in another isosceles triangle in which 180 minus 118 divided in 2 becomes 31. So here x equals 31. On 5, the last example. So 5, when you work within the big triangles, this first big triangle over here, if I've got 50 and 62, and I add those things up and subtract it from 180, right here, this corner is 68. In this big triangle, right here, when I add the other to 53 and 80 up, this guy becomes 47. To get this angle right here, a little angle in the triangle, add up 47 and 68, subtract that from 180, and you get 65. And x is the vertical angle to that, so x is 65 also. Okay, so this should be enough to get you through to the homework. Again, most of the things that you know already. Alrighty, good luck.